calculus was invented in the 1600s by a man named Sir Isaac Newton. Sir Isaac Newton didn't publish his work for another 10 years after he invented it, which gave time for a German named Leibniz to claim the idea as his own.
9!
Well, of course, this topic is still highly debated in mathematical circles, per se, but in my personal research, I have proven that Sir Isaac Newton is the true father of calculus.
Oh, hello. I didn't see you there. You know, a lot of people know what algebra and what geometry or even trigonometry is, but calculus isn't explained as well. A lot of people have seen the movie Stand and Deliver, which gives a pretty basic explanation of the study of mathematics.
6 times 9, 1, 2, 3, 4, 5, 6. What do you got? 54. Yeah.
A fundamental aspect of calculus is understanding derivatives. Now, a derivative is a slope of a line on a graph at a specific point on that line on the graph. So, for instance, if the equation of the line is y equals 2x, then the slope of the graph is 2 for the entire line. So, at a very specific point, the slope would be 2. It gets trickier when the slope of the line changes. For instance, if the line was y equals x squared. For a real-world example, what if we were to graph the velocity of a car driving along a road? Now, as the velocity changes, the car is accelerating. The acceleration is the derivative of velocity.
Another fundamental part of calculus is the integral, the reverse of the derivative. The integral of y equals 2 is y equals 2x. Going back to our car scenario, the integral of acceleration would be velocity, and the integral of velocity would be distance. In calculus notation, the derivative of f is f prime. So I guess you could say that if Optimus was a robot, his derivative would be Optimus Prime.
Now, I know what you may be thinking. How do I use calculus? Well, in mathematics, a common application of calculus is to find the area under the curve on a graph. For example, if you were to graph the equation y equals x squared, then the first step in finding the area under the curve would be to integrate it. Now, I'll save you some time. The integral of y equals x squared is 1/3 x to the third. So, you would plug in your minimum and maximum x values into that equation, subtract the minimum from the maximum, and you'd have your area under the curve. Now here's a little math joke for you. Why did the 7th grade girl always travel in groups of odd numbers? Because I literally can't even right now. Thank you very much.
A way of finding the derivative for simple equations is the power rule. The power rule is x to the n becomes n x to the n minus 1. In a real-life scenario, this would be x to the third becomes 3x squared. So to find the integral, you reverse it. X to the third would become 1/4 x to the fourth.